Hi, today we are going to discuss about OSI reference model in computer networks. Before going to that, why we need a reference model in computer networks? OSI reference model is nothing but open systems interconnect, which are a set of rules which describes how the computers and other devices should communicate in a network. This provide a set of rules for the communication process that are used in different devices. And what is the need of a reference model in any network? Imagine you and your friend are sharing messages. You are having a mobile, and your friend is having a computer system or a desktop. Without a set of rules, your device and your friend device might not understand each other. That is where OSI reference model or any reference model will step in. This is nothing but a guidebook or a translator which helps in breaking down the communication systems into different set of rules or layers in which each layer provides a specific job, like packing the message and sending it, and also addressing it, and also decrypting the message in the receiver side. So this is the important use of OSI reference model or any reference model in a communication network. Now we are going to discuss what is open systems interconnect reference model and how many layers are there in this OSI reference model. I already said OSI model stands for Open System Interconnect, where open stands to say non-proprietary. I already said it is a 7-layer architecture with each layer having its specific job to do, to perform. All these 7 layers work collaboratively in a network to transmit the data from one system to another system or across the globe. As I already mentioned, Versailles reference model has 7 layers. The bottom layer and the first layer is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. In the client side, the communication works from application layer to physical layer, and the receiver side, it will perform from layer 1 to layer 7, that is physical layer to application layer. And now we'll get into this. No, we'll get into the bottom layer, that is physical layer. So physical layer deals with bits, mainly deals with bits. The data is in the form of bits in the physical layer. Physical layer receives the data in the form of, and the client or the receiver receives the data in the form of signal, and these signals will be converted into bits which are called as zeros and ones, and this physical layer converts the signal into data into bit form, and these bits are transferred to the upper layer, that is data link layer. Physical layer also deals with the physical connection of the nodes or computers in a network. The main functionality of the physical layer is bit synchronization, bitrate control, physical topologies, and transmission mode. These are the main functionalities. Bit synchronization is nothing but this layer provides the synchronization of bits by providing a clock. By using the clock, the bits will be transferred in a specific format. In the specific format, by using a clock, the bits will be transferred to the receiver side. Bitrate control. It is also decides how many number of bits should be transferred per second. Physical topologies, I already said physical layers deals with the physical connection of the computers that are present in any network. So this mainly deals with how different devices or nodes are arranged in a network. These are different types of topologies such as bus, star, or mesh topology. Topology is nothing but how the computers or systems will be connected in a network. The systems or computers in the network can be connected using different topologies, and those topologies will be different types, that is called as bus, star, mesh, and different types of topologies. And also transmission mode, how the data flows between two connected devices. It can be simplex, half duplex, or full duplex. one-way communication is also possible. It can also be two-way communication. Both sender and receiver will equally participate in sharing the data. Next is data link layer. The data link layer will receive the bits from the physical layer, and these bits will be converted into in the form of frames. Data link layer will convert the bits received from physical layer and uh, format it in the form of frames. So the data link layer is also responsible for node to node delivery. If the data link layer receives a packet of data from the network, and the main responsibility of data link layer to make this packet travel from node to node in a network and make sure, and data link layer main responsibility is also to transfer the data error free and uh, error free from one node to another node. It mainly deals with error control and flow control. Flow control is nothing but uh, the data rate must be constant. The sending and receiving of the data speed should be constant. It is called as flow control, and it is maintained by data link layer in the uh, computer networks. It also deals with error control. This layer provides different mechanisms for error control in both sides. It also provides physical addressing. It is mainly responsible for adding physical address of the receiver and sender side of to the header of the frame. The frame uh, contains payload data and also header. The header contains the physical addresses of the receiver side and sender side. I already said what is framing. It provides a way for a sender to transmit a set of bits that are meaningful to the receiver. What is meant by meaningful? Because in data link layer, it adds physical address, or the MAC addresses. We can say that MAC addresses, medium access control layer addresses to the data. And also it has another functionality. It is called as access control. When a single communication channel is shared by multiple devices, this layer decides which device has control over the channel at any given time. At any given time, this layer decides which device or which node to have access over the network. These are the main important functionalities of data link layer. Next, we'll see network layer. Network layer is mainly responsible for host-to-host delivery. I forgot to mention, in data link layer, it is responsible for node-to-node delivery. In network layer, it is responsible for transferring the data from host to host. One host in one network to different host in another network. Host-to-host delivery means different networks. It will connect different networks in different systems. The main job of this layer is to maintain the quality of the data. It is also responsible for assigning logical addresses. Logical addresses are nothing but IP addresses that are given to the data or that are given to the network. Network layer is responsible for assigning logical addresses to any device in the network. Every device have a specific IP address. By using this IP address, the message is transferred from one host to another host in a network. And it also provides routing. Routing is process of identifying the best route from one router to another router. As I already said, it travels from host to host. To make sure the the data is transferring from host to host, it should be able to travel through different routers. And network layer provides a main functionality that is called as routing. And routing is the process of identifying the best path to transfer the packets from one router to another router and from one host to another host. And host to host delivery, as I already mentioned, network layer is responsible for host to host delivery. It forwards packets from each router to another router until it reaches the destination securely. It also provides security. Logical subnetting is nothing but it divides the network into smaller chunks of network known as logical subnet. Fragmentation in reassembly is nothing but any network will have a certain transmission unit. The network allows only certain amount of data to be transferred at a specific time, at any single time. So that is called as maximum transmission unit. Any network will have this maximum transmission unit. And fragmentation and reassembly functionality in network layer provides the data provides and sees that the data fragments are fragmented into more smaller packets so that they can fit the size of maximum transmission unit in any network. It also provides congestion control. If there is any excessive load on the network which it can't handle, the network layer provides different congestion control algorithms to avoid that. These are the main functionalities of network layer. Next layer is transport layer. In transport layer, the data will be in the form of segments, and it is responsible for end-to-end delivery. End-to-end delivery is nothing but process to process delivery. Process to process delivery, we can be see as it can be defined as one application to another application, like WhatsApp to Facebook. Different applications use different processes. So it is mainly responsible for end-to-end delivery, which is also called as process to process delivery. Process to process delivery means one application to another application. If I am using WhatsApp in my system, there also my friend is using WhatsApp in his system. To see that the message is going from my WhatsApp to his WhatsApp in his system, transport layer is responsible to make sure correct port addresses are given. In transport layer, transport layer assign port addresses to the data, to the segments, because it is dealing with process to process delivery. It is dealing with end to end delivery. Delivers data across network connections like TCP. Different transport protocols may support a range of capabilities, including error recovery, flow control, supports for retransmission. Every layer provides error control and flow control, and transport layer also deals with no mainly deals with process to process delivery. That is called as end to end delivery. The main services provided by transport layer are connection-oriented service and connectionless service. Next one is session layer. The session layer is mainly responsible for establishing, maintaining, and ending sessions across all the channels. It also maintains and manages the sequence of what is the sequence of the data that should be transmitted across the network. And session establishment, I already said what is session establishment. Establishing the connection between two devices, between devices. And also this is a dialog management, is nothing but giving log data. It manages log data on which connections are established to transmit and receive data, which is called as dialog management. Synchronization is nothing but it gives synchronization bits to every message to define or to know the state of an error, to know when the error occurs or when it will be ended. It also provides authentication and authorization for the user that are transferring the data in the computer network. Session layer is responsible mainly for authentication and authorization. Next one is presentation layer. As I already said, in computer, in during the communication, the data should be encrypted and decrypted. The data should be encrypted from the client side and decrypted in the receiver side. So presentation layer mainly receives the data from the application layer and required format and are manipulated as per the required format to transmit over the network. I already said encryption and decryption, encapsulation and decapsulation of the data will happen in communication channel over the network. So presentation layer takes care of that. Encryption and decryption. Data encryption translates the data into another form of code. The encrypted data is known as ciphertext. The decrypted data is known as plain text. So compression, it also reduces the number of bits that need to be transmitted to the network. Next, application layer is also called as desktop layer. These application produce the data which has to be transferred. The data that all the layers receive will come from application layer. Application layer mainly is responsible for producing the data that has to be transmitted over the network, over to all the layers that are present in the network. The user has to log in and log out from any application. So application layer provides a network virtual terminal for every user to do these set of functionalities in any application or in any desktop network. So file transfer, access and management. File transfer, the application layer uses different types of protocols such as FTP, SMTP and all. They can be used for file transferring and management. Mail services, electronic mail services and directory services. OSI model acts as a reference model. We can take example as browsers, Skype, Messenger, etc. So application layer also, in application layer we can see domain name system, DNS model, which can be used for transferring the data from one system in a network to another system in a network. Application layer also mainly deals with this DNS, and DNS is very important for transferring the data in a communication channel. Thank you.